Hello everyone. In the previous video, we studied this pseudocode where we inserted node in the beginning. So a quick revision of what we did in the last pseudocode is we inserted a node in the beginning in linked list. Now, I forgot to mention there that we are working on a singly linked list right now. So here, insertion in the beginning means we are inserting the node in the singly linked list. Okay, so the concept that we are studying is a singly linked list. Okay, and singly linked list has, again, just quick revision. Singly linked list has node having two fields. One is the data field and other is the next field. Data holds the value of any type, integer, float, character, and the next field of a node holds the address of the next node, right? So this is how the singly linked list node looks, and we see that how we can insert the data in the beginning. Now, given that particular linked list that we have studied in the previous question, so this was the, sorry. So this was the list that we created in the last time. Now, I'll redraw this linked list again. And now let's assume that in my linked list, there are two nodes. Okay. So the first node was 4 here, which is pointing to the next node. The next node has value 10 and it is pointing to null. That means there is no node after that. And because this is the first node, its address is stored in the start variable, start pointer. So start is having the address of the first node. Now let's talk about the second concept where we are going to insert the node at the end. Okay, so we are going to understand how insertion should happen. I'll write your singly linked list, insertion in the singly linked list at the end. So we need to know how to insert the data in the linked list at the end. Now for that, we need two things. First is we need to understand the concept of traversing, right? Because we have to traverse to the end. We have to traverse to the end of the linked list, right? And then we are going to insert. So here it takes two things. First, we traverse the list and then we insert the data at the end. Now, why we need to traverse? Because as I mentioned, we know only the start address. We don't know the addresses of all the nodes. Once the nodes are part of the linked list, we don't know their addresses. The addresses of all the nodes, it's not possible for me to remember the addresses of all the nodes. That's why I only remember the address of the first node. And then I can use this link to get to the next node, right? So we need to access this list. And for that, we need to access the node. And we know that in a linked list, we can access only first node because its address is present in start. So we have to start from this address and then we can fetch the next address. Now let us understand this with one more thing, one more extra pointer, because remember, as a programmer, we don't disturb the start pointer because it will always hold the first address of your linked list. If you have by mistakenly changed the address of the start, you are losing out the nodes. You are losing out the first node. And if first node is gone, then all the other links have been gone. So remember that you have to be very careful with the start pointer. So we generally don't use start pointer for traversing. And for traversing, we use another pointer. Let's say I call that pointer as PTR. You can give any other name also. I'm calling it as PTR. Now PTR takes the address of start. That means what a start is holding, it is holding the address of this first node. So what we do, we use PTR, and PTR is also updated with the start address. So now PTR is also pointing to this first node. Okay, now what we tell this PTR to check the address at the next field of each node, right? Of each node, check the address at the next field, right? If there is an address, that means that there is surely a next node after that. But when there is null in the next field of any node, it indicates that it is the last node. Now, this is what the logic behind traversing. Okay. So what we are seeing here is, I will right now write some rough stages. The first step remains the same. That means we're going to, because we are going to create a new node, so we need to take it from a heap. So we'll say that if avail equals to null, it indicates that there is an overflow condition, that means there is no memory left to assign. Okay, and we simply exit. So we'll say go to step, and now here we need to wait for that exit step. Which number is that? So we'll write it later. Now step 2 is, what we do is first we create. So again, step 2 remains the same because we have to create a new node. So here, how to create a new node? I will say set new node equals to, and we are taking it from avail memory location, right? So we are taking it from avail heap. Okay, basically we're taking it from memory. Now, step number 3 is, again, this is not mandatory, but it is just a way to say that we are also keeping, the computer is also keeping track of the next available memory for the user. So that is what we are writing here. So avail arrow next, right? Now, coming to the main concept here. So as I mentioned here, before insertion at the end, we need to first traverse, right? So for traversing, we need to use a new pointer, which is PTR, and we will give this the address of our start node, right? Because start is holding the address of the first node. So we're going to use that PTR, which will update with the address of the start node. Now, once this is done, what we have to do is we have to traverse, right? We have to traverse. And for traversing, uh, because we don't know how many nodes are there, so it's a repetitive process. What is the process here? For every node that we are pointing, we have to check its next field. Only if it is null, then we are reaching to the next pointer. Otherwise, we have to go to the next address, right? So here we are saying while ptr arrow next is not equal to null, right? This is the condition that we are checking, right? We have to repeat the next step. Okay, so we have to repeat the next step. Now, what is the next step? If it is not null, this PTR has to come to the next node. Now, how do we do that? So PTR arrow next is not null. So PTR should jump here. Now, how do I get the address of this node? It is present in PTR arrow next. So PTR should be updated with PTR arrow next. So here we are saying that if your PTR arrow next, that means this field, because PTR is pointing over here right now, PTR arrow x, is it null? No, because there is some address. So this condition is false. So let's update PTR. How do I update PTR? We'll say PTR equals to PTR arrow next, because PTR arrow next is holding the address of the next pointer. So the moment I do this, your PTR now points to this node. Now it checks again. Now if this node becomes PTR, so PTR arrow next is null? Yes, because this node has the last value as null. And therefore this condition becomes false. So we come out of the loop, right? So we're repeating this, sorry for the spelling here. Okay, so we're repeating this step for the number of times till we do not find that null in the node. And now once that is done, what we do is we have reached to that last node. Now here we have to add a new node, right? Now how do I add that new node here? So basically we have to create a new node, right? Because we can clearly see that we have created a new node. Now we just have to attach that to the last part. Now how do I attach? So basically here the address of that new node should come, right? So once this is done, we're simply going to say that, okay, ptr arrow next, because we have reached to the last point node, which is pointing by PTR. So we are going to put in its next field the address of the new node. That's it. Okay. Also, we can do one more thing, that we have to set new node arrow next. Now this you can do in the beginning or in the at the end also. New arrow next will be null. Now why it is null? Because we are performing here insertion at the end, right? So this is insertion at the end in singly linked list, right? So when we are inserting at the end of the singly linked list, this new node is the last node of your linked list, and that's why its next field will be always null. Okay, and once this is done, we will simply stop. So here we are going to exit. So here the step number 9 will come. So if we have available memory, then this will be false. We come to step 2. We create a new node, and then the available memory we will point to the next available node. Then we use a new pointer PTR because we do not disturb the address of the start node. So we use a new pointer PTR until that PTR arrow next. So PTR, whenever it is pointing to any node, we check the next field of that node. So PTR arrow next. If I'm not getting null at that location, I will keep jumping to the next node. How you keep jumping? This is called traversing, right? So this is a traversing logic. We keep jumping to the next location by updating the address of PTR. How do I get the next address? From PTR arrow next. So the PTR arrow next address will be stored in PTR. And this is how you are going to reach to the last node. So once you are at the last node where the next pointer is null, now you attach that new node to this. So this address has to be updated. So PTR arrow next has to get updated with the new node address, and new node arrow next. The new node's next field should be made null, which means it is the last node of your linked list. So this is how we perform insertion at the end in the linked list. Thank you so much.